Good morning, students. Today we are going to discuss about types of force. Types of force are two types: contact force and non-contact force. Yesterday we are already discussed about contact force. In contact force, there are two types. One is muscular force, another one is friction. Muscular force will generate due to action of few muscles. This muscular force we use every day to walk, to run, to lift an object. All this are a muscular force. This muscular force come into play when there are two or more other objects are in contact, are in physically in contact. Then only this muscular force will exist. Similarly, the frictional force. Frictional force is a force which always acts opposite to the applied force. It always acts opposite directions to applied force. So which makes the object to change the state of motion. Suppose if you roll down the ball on the ground, after going to some distance, it is going to stop. Yesterday we have seen the video about it. Right? I hope you have solved the homework questions of yesterday. And today, mainly we will focus on non-contact forces. What first we need to understand what is this non-contact force. So we already understood contact force. Contact force means the force which comes into exist when the two objects or two or more objects are in contact. Similarly, non-contact force is a force which acts on an object without coming physically in contact with it. That means they won't touch at all, but still the force exerts on another object. Right? So this contact forces are non-contact forces are again classified into three. So one is magnetic force, gravitational force, and electrostatic force. So we will discuss one by one these forces. So first we will discuss about magnetic force. So in your earlier classes like 6th standard and 7th standard, you saw the magnets like a bar magnet, horseshoe magnets, and how the bar magnet attracts the iron, and you have seen it, right? So before I discuss about this, before I discuss this, how the magnetic force is named as a non-contact force, let us do an activity. Okay. Here I have taken two bar magnets, one non-metallic ball, compass, metallic ball, and ramp. First, let us play with two magnets. So I have taken the two magnets here. Both are same poles. Means this red is north and white is south. So north, how it's happening here? Are they are going to repel. Look at that. So one is pushing the other. That means still there is exist a force on other object. Now look at. Now one is south and another is north. So they attract. Beginning they are not in contact, but still it will pull towards it. One will pull towards it. Now let us see how the metallic ball will be deflected by a magnet. So this is non-metallic ball. Non-metallic ball means it's a magnet. So suppose it's a plastic. It's not deflecting. Look at now a metallic ball, how it is deflected towards the magnet. That means the iron will be attracted towards the magnet. Look at again. So it is going to deflect. It's going to attract towards the magnet. And you have seen this compass. So look at here. This is a compass and a bar magnet. Here the compass is also a small magnet which is situated on a pivot. It is free. So this compass is just a magnet, and this bar magnet is also a magnet. So similarly the north and north will repel, north and south will attract. So you can see the further how it is going to vibrate. It's going to it's going to rotating, but still they are not in contact. But still that is rotating because of the repulsive force. Right? Okay, so we have seen that video and how the magnets were attracting before they are coming into contact. Means they can exert a force even when they are not in contact. That's why the magnetic force is called as non-contact force. Right? A magnet can exert force on another magnet without being in contact with it. The force exerted by a magnet is an example of non-contact force. Suppose we have also seen that like poles of magnet repel each other. That means north will repel, south will repel. Unlike poles of a magnet attract each other. Means north and south will attract, right? So these are things we have studied since on the video. Now we'll go to the next non-contact force, gravitational force. This is every day we require this one. Otherwise, we cannot walk on the earth. Right? So earth will always pull an object towards it. Object or things fall towards the earth because of it pulls them. So earth is going to pull the objects towards it. So this force is called as force of gravity. The earth pulling the objects towards it is called as force of gravity. Suppose if you throw in any object upward, it always comes towards the earth. Whatever the object, whichever the object you throw it, irrespective of it, metal you throw, plastic you throw, anything you throw, it will come back again to the earth because earth is going to pull them towards it. And this force is always an attractive force. This force is an always attractive force and it's a non-contact force. Remember, this is a non-contact force because it can exert without being them in contact. The force of gravity acts on all the objects, so irrespective of it, it acts on it. The gravity is not a property of the earth alone. It is not a property of the earth alone. Every object in the universe, whether small or large, exerts force on every object. This force is known as a gravitational force. Right? So everything in the universe has a gravitational force. If you go on the Mars, there is a gravitational force of the Mars. If you go on a moon, there is a gravitational force of the moon also. So we come across more about this gravitational force when you go into the 9th standard. There is a chapter, it's called the gravitational force. We'll study more about it. Now, so we'll take a next, the non-contact force, that is electrostatic force. Right? So before going to that topic, let us see this. You can also perform in your home. Take a comb and take a piece of papers and make them to lie on the table. Then take the comb and comb your ears. Comb it properly. Rub with your ear. Then bring near to that piece of papers. So look at that, how it is going to attract. If you didn't rub that comb, it won't attract. So whenever you rub it, it is going to attract. Look at here. So why it's happening? Right. So here, this force is a different kind of force. This is also non-contact force anyway, but it is coming due to the charges present in it. The charge is a property of every matter. Every matter has a charge. Like you heard about electron and proton, all these are charges. So we come across more about charges in our later classes. Now look at another video on electrostatic force. So carefully you look into this.
Topic: electric charge. Huh? How does a plastic comb attract paper? What? You don't believe me? Okay, let us try. Take a plastic comb and bring it close to some pieces of paper. Hey, wait. Don't laugh. We need to do something first. Rub the comb on your dry hair and then bring the comb close to the pieces of paper. See? I was correct. The pieces of paper got attracted to the plastic comb. Do you think it is magic? No. The reason behind this is electric charge. Electric charge is the quantity of electricity held in an object. There are two types of electric charges, positive and negative. However, there are some objects where the positive and negative charges are equal to one another. In such cases, we say that the object is electrically neutral. So, was the plastic comb initially electrically neutral or electrically charged? Initially, the plastic comb was electrically neutral. That means it had an equal number of positive and negative charges. Hence, it did not have the ability to exert a force and attract the pieces of paper. So, after rubbing the plastic comb on our dry hair, why was it able to attract the pieces of paper? I will tell you why. When we rubbed the plastic comb on our dry hair, it gained an electric charge. Once it got electrically charged, it got the ability to exert a force on the pieces of paper and attract them. This charge is called as static electricity. However, do you think, like a plastic comb, a metallic comb would also attract the pieces of paper? Nope, you are wrong. A metallic comb will not attract the pieces of paper like the plastic comb. Wondering why is that so? It is because plastic is not a good conductor of electricity. It does not allow the electric charges to flow through it onto the earth. As a result, the charges build in the plastic comb, making it electrically charged and enabling it to attract the pieces of paper. However, metal is a good conductor of electricity. It does not let the charges build in it. It allows the electric charges to flow through it onto the earth, thus not allowing the metallic comb to get electrically charged. As a result, the metallic comb does not attract the pieces of paper.
So we have seen this video and we have understood that there are some charges. When you rub the comb with your hair, the charges will transfer to the comb and only you have to use the plastic comb, not the metallic comb. So when you use the plastic comb, the charges will transfer from your hair to the comb. Okay, it will acquire some charges, and when you bring near to the piece of paper, due to that charged comb, it is going to attract. So let us define this electrostatic force. The force exerted by a charged body on another charged or an uncharged body is known as an electrostatic force. So the force exerted by a charged body on another charged body. It can exert a force on another charged body also, or it can exert on a uncharged body. Here we have taken a comb we are going to charge by rubbing, and the piece of papers were uncharged, and charged body is attracted to an uncharged body because both were having different kinds of charges. And force coming to play even when bodies are in non-contact. This force is coming to play even both the forces are not, both the objects are in non-contact. So that's why it's named as non-contact force. Okay, having understood all these topics, so let us solve these homework questions. I'm giving you three homework questions. So one is fill in the blanks, which was in the last slide, and second one is two persons are applying force on two opposite sides of moving cart. The cart still moves with the same speed in same direction. What do you infer about the magnitude and direction of the force applied? So try to solve this. That is related to the first video, and answer textbook exercise questions 7, 8 and 9. Thank you. Stay home, stay safe.